last thing we have to classify are combustion reactions. Combustion reactions always will form carbon dioxide and water as products. It'll always have some carbohydrate or hydrocarbon and oxygen as reactants. And these are important because these are the fossil fuels that we burn in our cars and in our homes and in our grills. All right, so here's an example. If you had ethane plus oxygen, you're always going to make CO2 and water. So the nice thing is these are a piece of cake to predict because they always make carbon dioxide and water. All you have to do is recognize that the reactants are some carbon, hydrogen species and oxygen. So that's what you're burning. So anything you burn in this situation, like butane or propane or paper or wood, that's all sort of what's happening here. Is you're taking some carbon and hydrogen, burning it in the presence of oxygen to make CO2 and water. And so this is where all that CO2 is coming for the environment. All right. So the hard part about these is not predicting the products, CO2 and water. No, not a problem. The problem with these is the balancing. It's not terribly hard, but the issue becomes that the oxygen goes to two places. So oxygen goes to two products. It's the only one that does that. And because of that, we wanted to use that last. So do that one last. All right, since oxygen goes to two products, we should do that last. So if we're doing the carbons, every one of these is going to do CHO. So the carbons on this side is 3. The carbons on this side is currently 1. So we want a 3 there. So we have 3. The hydrogens on this side are 8. The hydrogens currently on that side are 2. So we want 4 times 2 to make 8. The oxygens, now this is where it gets a little hairy. So the oxygens is 3 times 2 is 6. And 4 times 1 is 4. 4 plus 6 is 10 oxygens. And they all come from this O2. Thankfully, that's an even number. And since they come in pairs, that won't be a problem. We just put a 5 there and we get a 10. So that's not a problem there. This next one, carbon starts here. There's 4. They all go here. We want a 4 there. Hydrogens start here. There's 10. They all got here. So that's 5. 5 times 2 is 10. Oxygens, here's going to be the issue. 4 times 2 is 8 plus 5. 8 plus 5 is 13. Now we got an odd number. And an odd number can't come if we're having oxygen in pairs. So there's two ways to address this. One is odd number times 2 always gives you an even number. So we can just multiply everything by 2 and it'll work out. All right. The other way you can see is if I need this to make 13, it'd be nice if there was a rule that allowed me to use fractions and I would want 13 halves. But since I can't have fractions like that, I multiply everything by 2, so I get to the same place. So either way, you're multiplying everything by 2 because of this odd even situation with oxygen. So this is going to become 2 of these. This is going to become, it was 4, it's now 8. This was 5, it's now 10. So I now have 8 carbons on this side and 8 carbons on that side. 10 times 2, I now have 20 and 20 with the hydrogens. But now my oxygens are 16 plus 10, which is 26, not 13. So if I'm trying to get 26 out of this, I just need 13 of those to get 26 there. All right, so this last one, there's actually some oxygen involved in our first thing, so that's a little different. But same situation, 6 carbons, they all go there. 12 hydrogens, they all go there. 6 times 2 is 12, so we got 12 and 12. Oxygens, now oxygens is coming from two places, so 6 times 2 is 12, plus 6 is 18. We need to make 18. We already got 6. So 18 minus the 6 means 12 has to come from here. So in order to get a total of 18 here, we need 6 O2s to give us 12 plus the 6 that's in the sugar. 12 plus 6 is 18, and everything's equal.